You hit a question like this that gives you a way to find the slope at any point. It's a separable differential equation. That is one of the things I knew about it, that if I wanted to get everything kind of done, dy over y is equal to x dx over 2. But let's presume that we don't have a calculator on this. And so even if I integrate both sides, I get a natural log on the left side. That's not going to necessarily help if I want to figure out its values. And that plus the first question on this, first thing said, sketch a slope field for the given differential equation at the 9 points indicated. This would be common for a question that you would see on this. It's only going to give you a few points. And in fact, 3 of them are going to be slopes of 0, right? Because at all those points, the x value is 0. And here on the y value, the slope is going to be the same as the y value divided by 2. So this is a slope of 1/2, which is going to be not as steep as 1. This is going to be a slope of, if I plug in 1, 2, I get a slope of 1. And this is going to be a slope of 1.5. So just kind of flatter, middle, and then steep. You see how they just do a gradation? Even if you don't really have a great distinction, you can still get flatter, middle, and steep. And then these are just going to be the negative versions of this. So exactly the same, but just kind of moving the opposite. Flatter, middle, steeper. So that's good enough for what this is going to want. So that's a slope field. It's not going to actually ask you to trace the solution on this. It just wanted to get this down. So I don't know why, that's what I drew. I drew something like that because I just thought little tick marks that I have the slopes at the different points because there were 9 different points. Here's the tricky one. It says, let f of x be the particular solution to the given differential equation with initial condition of f of 0 is equal to 3. If this is separable, and this one is, we could actually solve that, but that's not what the question's asking. It's asking, using Euler, yes, pronunciation's a thing here, Euler, not Euler, as a method starting at 0 with a step size of 0.1 to use that to approximate f of 0.2. I didn't know what that meant. I don't think you do either. But I knew that at x equals 0, y equals 3, because that was given. And I knew that the problem would work with something that was given. I also know that at x equals 0, dy over dx, which is the slope, is what? 0. Because I know, and I'm going to copy it right here, I know that dy dx is equal to xy over 2 in this problem. So at x equals 0, 0 times 3 over 2 is 0. I was compulsive about showing work because it literally did say, show the work that leads to your answer. Actually, if it's literally said that, it'd come out of the page and talk to me with a voice. That's not literal, but so we'll say it figuratively said that. Okay, at x equals 0, this is 0. This was the moment of like zen for me. I know that we're starting at 0, 3. That was like right up here. I thought of this as like an arrow. And it said, okay, now go that way. Like figuratively travel that way. And it said a step size of 0.1. So it meant go 0.1 that way. So where am I going to end up if I go 0.1 to the right? What ordered pair am I going to end up at? 0.13. I'm going to end up at 0.13. So that is the next little step. At x equals 0.1, which is 1.1 over, we are still at y equals 3. Now, I knew that. I'm going to slide this down a little bit. I knew that because the dy dx was 0. So what I was kind of doing is I was going to say y is equal to my dy dx times the step size plus my initial y value. That looks complicated until you realize what it's actually doing. I have a y value of 3. That's where I am. I'm going to go over 0.1, and I want to know if I go over 0.1, how far up is that by slope? Like, because slope is about over, up, over, up. Well, my slope was 0, so if I take 0 times 0.1 plus 3, I get 3 again, which means that at x equals 0.1, we have the same y value. Okay, that means I've moved 0.1 over to the right. In this problem, where do I want to end up? I've moved 0.1. I want to move 0.2. So I'm going to take one more step. And this is the tricky one right here. This is the whole point of the problem. Y is equal to, I'm going to do dy dx again, which means that, okay, so I need to know what my new slope is at this ordered pair. So I'm going to kind of come back down here. Now at x equals 0.1 and y equals 3, what would my slope be? 0.1 times 3 over 2, which is 0.3 over 2. If you want to express that in a decimal, that's half of 0.30. So that's 0.15. Or if you want that as a fraction, that's 15/100ths. It's 3/20ths. I like fractions better, so I'm going to call that 3/20ths. I'm going to come back to this equation. Y is equal to dy dx times my step size plus my previous y value. I'll call that y sub 0.1 because that's where we were at 0.1. I didn't use this notation back then. I used it now. But okay, so our new y value, what's my slope again? 3/20ths. My step size means I want to take 3/20ths and I want to use that to change moving over 0.1 into how far up I'm going. Plus my previous y value. What was my previous y value? 3. So I get y is equal to, 3/20ths times 1/10 is 3/200ths plus 3. So I could say 3 and 2 and 3/200ths. I could say 63/20ths. Or I could take that 0.1 and say that that is 3.01215. All that math you could do without a calculator and figure out the best way to do that. So then I get y is equal to 3.015. Okay. I want to show visually what you kind of did, because I'm going to kind of come back up to this thing. At this point that we ended up at, my slope was now 3/20ths, and it said, now go in this direction. So what I sort of did was I drew a mini triangle where I said, okay, so then if I go over 0.1, that'd be the same as going up 0.15, because that would be a slope of 3/20ths. Where would my new point be? It'd be 3 plus the 0.15. Actually, this should be 3.15 right here, not 3.015. I'm not mathing well. So that's kind of where I settled. That was sort of the, I want to say the trick of this, but that's, oh no, that would be 3.015. Because over 0.1 is the same as up 0.015. Like over 1, up 0.15. Okay, let's go to the last question. I was like praying that this was going to be an easier question because that took a lot of time. Find a particular solution with the initial condition of f of 0 is equal to 3, and use your solution to find f is 0.2. Oh, this means actually plug this in. So this is like, it's a separable differential equation. dy dx is equal to xy over 2. We separate it. dy over y is equal to x dx over 2. Then I take the integration, natural log of y is equal to x squared over 4 plus c, which means that y is equal to e to the, well, we can make that c e to the x squared over 4. It's a different c. Plug in 0. Get 3 is equal to c. So I get y is equal to 3e to the x squared over 4. And then plug in f of 0.2. So 3e to the 0.04 over 4. And if you do that, you get an approximate value of 3.03015. So you circle that, you compared it with the one right up above, and you said, oh, okay, they're close. And you smile, and you get your like 9 points on the problem.